Hey guys, welcome back. We're going to do a redox review, right? And when we talk about redox, think about when we have reactions. Reactants go into our products. But remember, all a chemical reaction is a rearrangement of atoms. And a redistribution of your electrons. All right, so we're redistributing electrons. So first, our little redox review from Chem 1 about how we count electrons, right? So the oxidation numbers are how we do it, all right? And it works out pretty good. So for example, all right, we learn the rules. The element by itself is 0, right? So that'd be Fe, F2, O2, chromium. They're all 0, 0, 0. There's no proton or no electrons gained or lost. Same number of protons as electrons. All right. So for iron, if you look at this, iron has 26 protons and 26 electrons. So there's no oxidation state. So element by itself, we'll just highlight that. So element by itself is 0. A monatomic ion is the charge. Right? What do we mean? So we would have, let's say, Fe3 plus, O2 minus, Cr2 plus, right? These charges are your oxidation states. Right? And so if we go back to iron, still has 26 protons, but now it only has 23 electrons. All right. Fluorine. Fluorine is -1 in compounds. Period. What's the only time fluorine's not -1? Right there. F2, 0, right? F2. Fluorine as an element. Otherwise, fluorine's -1. All right. Oxygen is -2. But now there's some exceptions. All right, there's some exceptions. Like you have OF2, where oxygen is going to be a different charge. You have the peroxides, O2, 2 minus, superoxide, O2 minus. And so oxygen becomes +2 in oxygen difluoride. Peroxide, it's -1 and -1/2. Well, how do we get that? Well, glad you asked. You have O and O, right? Well, let's make this a little bit better. So when we bond 2, 4, 6, 8. Well, how many electrons do we have? We have 13. So there's 8, 10, 12, 13. And so what happens here is there is a lone pair, or a lone atom, not a lone pair. There is a lone electron, not paired. That's better right there. But there's resonance with it, right? So one of these oxygens is, right, if you look at it, one of them is -1, which the left one's a -1 right now. The other one's 0. Right? Well, but because there's resonance, we just do it -1/2. All right? And there's some other ones too, but we're not going to, like the hydroxyl radical and whatnot, but we're not going to go into it. All right, the halogens. The halogens. Chlorine, bromine, and iodine. They like to be -1 unless they're paired with oxygen and fluorine. Right? That means they are, right, a central atom. Right? What do I mean? Right? ClO3 minus versus COCl2. All right. In chlorate, chlorine would be, what's that? +5. In the COCl2, chlorine's -1. What we'd expect. Now hydrogen. Hydrogen H can be +1 most of the time, but it can also be -1 with metals. What do I mean by that? That would be like NaH, LiH, and I put a K down. Let's go with H. All right, sodium hydride, lithium hydride, calcium hydride, CaH2, right? That's what's going on there. And then finally, group 1 is +1 and group 2 is +2 in compounds. All right, always. All right, we have not observed it otherwise. All right, it's at least stable. Okay, now, polyatomic ions and molecules. Right, the oxidation number of an element in a molecule is the charge the atom would have if the electron in the bond were assigned to the more electronegative atom. So that's a way to figure it out. So if you have N and C, well, nitrogen is the -1, carbon would be the +1. Now, how I like to do this, if I have elements X, Y, and Z here, all right, the oxidation numbers are up here. Down below, I like to do my math help. And if you don't know, I'll show you this in a second. And the math help, overall, it equals the charge. All right, so it might be 0, it might not be 0. All right, so let's do some examples. All right. So we got iron. Iron metal. Well, is it an element by itself? Yes, it is. 0. N2. Is it an element by itself? Yes, it is. 0. HCl. Not an element by itself. Monatomic ion? No. So if you go through your rules, all right, we got chlorine and hydrogen. Well, chlorine, it's not paired with oxygen, so chlorine likes to be -1, and hydrogen likes to be +1. Does that work out? Well, because there's no charge, it adds up to 0, -1, +1. It does work out. Let's do another one. SOCl2. 0 equals 0 because that's the charge. Who do we start with? Because it's not a monatomic, it's not an element by itself, not a monatomic ion, right? It doesn't have fluorine, but it has oxygen. Oxygen's -2. And so I'm just going to put a little -2 down below. All right, zoom in a little bit for us. And then if I keep going down my rules, chlorine's next. Chlorine likes to be -1, right? And so that's also, there's two chlorines, so 2 times the -1 is a -2. So that means underneath sulfur, +4 would have to make this work out. So sulfur is going to be +4. Right, that's how I would do it. So why do we do the math help? Because 4 minus 2 is 0. But 4 minus 2 minus 1 is not 0. And so a lot of us don't like to do math in our head. If you do, you don't have to do the bottom, but a lot of us like it. Permanganate, we add up to -1. Who do we start with? Well, if you go down your rules, I'm going to go with oxygen. Oxygen's -2. And there are 4 oxygens. So that's a -8. So that means manganese has to be 7. All right. Again, what do we want? We want these numbers up there, right? The bottom in blue, that's just for us, all right? But it's not necessarily, that's for us to count. That's not what we, that's not how we're going to predict. We're going to use the red numbers up top. Oh, we just went big. All right, so you got ammonium phosphate. Now, here's the thing you can do. you can always separate these. You can separate ammonium and phosphate out. So I have NH4 plus and PO4 3 minus. All right, if we take ammonium, you go down your rules, you got hydrogen. Hydrogen's plus 1. And equals plus 1. Oh, didn't change color on me. Keep going. It equals plus 1. So that would mean this is a plus 4. So nitrogen's a minus 3, which is what we expect. If you look at phosphate, oxygen's minus 2. There are 4 of them, so that's a minus 8. So that means phosphorus has to be plus 5. All right, let's see if this works out. So we have minus 3 for nitrogen, plus 1, plus 5, and minus 2. So that's a minus 8 there, plus 5, right? Which makes sense because that's phosphate being minus 3. Then we have 1 times 4 is 4, plus 3, plus 12. 3 times 3, minus 9. And that's a plus 4. So that works out. All right. So phosphate's always going to be phosphate. So phosphate's always going to have those 2 oxidation states. Ammonium's always going to have those 2 oxidation states. You don't have to memorize them. We can always solve them. But that's what we got here. All right. Now, this one, the next one, last one we're going to do. It looks long. What is iron's oxidation state? We should be able to tell this. Well, what do we have? You have OH, which is, in this case, what? It's hydroxide, so hydroxide is minus 1. You have water, 5 of them. Water is 0, no charge. Then you have nitrate, and nitrate's minus 1, and you got 2 of them. So you got a minus 1, and then a minus 1, and a minus 1. So that means iron would have to be, should be, plus 3. You should have iron 3 here. All right? Okay? But now if we do we can bring nitrate up if you wanted to. And O3 minus. We add up to negative 1. Nitrogen, or oxygen is minus 2. So that's a minus 6. So that means nitrogen is plus 5. All right, so we're going to have a minus 2 here, plus 1, minus 2, plus 5, and minus 2, right? So oxygen, hydrogen, when they're in compounds, pretty straightforward. All right, let's see. Add all this up. Does it work out? We'll go with 3 here, minus 2, plus 1, plus 2, plus 10, minus 10, plus 10, minus 12. And it does, right? So there's your minus 1. There's a 0, and there's a minus 2. So that's how we do oxidation numbers. Hopefully that's a review for you. If you have more questions, just reach out to me, and we'll help you. Otherwise, we'll see you in the next video. Take care.